I think let's get started. Hello everyone, welcome to Python Melbourne Meetup, and thank you for being with us today. So this is our Slack code. If you haven't joined the Slack, please feel free to scan the code, and you will get a scanner in the end of the slide as well. So don't worry about that. So before begin, I pay my respect to elders, past, present, and futures, who will continue to take care of the land. Code of conduct, our community is dedicated to providing an inclusive environment for everyone. So please have a read. Let's go to the social media. We are active on social media as well, LinkedIn and Mastodon. If you are active in social media, please give us a follow, and yeah, we will have activity in social media. Let's go to the sponsors. First of all, thank you to all sponsors. Judo Bank for providing the event venue, AWS for providing the pizza, and Style Education for providing us with the drinks. And if you have noticed, then we have a new sponsor, Style Education. So thank you, Ben, for making this possible. Yeah, before begin, I'd like to call on Michael for giving the information about the housekeeping.
Thank you all. Great to see you all here for another Python meetup. If you don't know much about Judo Bank is the SME bank trying to become the most trusted bank in Australia. We predominantly do a whole bunch of lending, term deposits, and such. Little bit about tonight. If you require the bathrooms, they're all the way past the elevators and to the right. And the bins are located over by the sinks over there. If you need any help with anything, please come find me, and I'll help you out as best as I can. And I hope you all have a great night. Thank you.
Michael? So now I'd like to request Ben to say something about the Style Education.
G'day, I'm happy to just talk out loudly. I work at Style Education. Style is a science education company used by about half of students in Australia to learn science. We're hiring pretty aggressively at the moment. We've just been bought by a company in the US, and they want to expand our product to every state in the US, which is pretty exciting. We're expecting to grow from 700,000 students to about 2 million students within the next 2 years, and probably more like 12 million students within the next 5 years, which is wild. If you're interested in science education, you're a software engineer with experience, I'd love to hear from you. You can chat to me after.
Thank you. So yeah, if you haven't scanned the Slack QR code, so please feel free to scan and join our Slack channel. We mostly update the information on the Slack channel only, so please free to join our Slack channel. Let's go to today's agenda. So we have two speakers, Akshat, Soni, who will be giving the talks on the Python design pattern, and Edward Schofield, who will be giving the talks on the better DataFrames with the Polars DataFrame library. So these are the today's agenda, and yeah, obviously the meetup. So with regards to the meetup, speaking, sponsorship, and volunteering, I'd like to request Ronaldo to have a voice.
Yep, thanks Mahesh. So yeah, pretty much just would like to, as usual, have a special word on regards to getting involved. So yeah, pretty much, more or less, there's not been too many changes from before. We're pretty much still looking for essentially those who are looking to help out with emceeing events as well, like pretty much like what Mahesh is doing as well. Aside from that, we're still looking for a sponsorships liaison as well, and pretty much to be able to help out with essentially securing sponsors, communicating with sponsors, maintaining relationships with sponsors and the like, essentially. And aside from that, we're still looking for, well, mentors is not exactly the right word, but we're pretty much like looking for more people essentially to get involved within the mentorship program, essentially to essentially help with coordinating it and essentially in running it, since it's pretty much like one of the things that we are still continually pursuing as well. And yeah, pretty much like soon we'll be opening the form for mentees as well, since we pretty much already secured the form for mentors in particular, and we already have like a good batch to start our run basically for the first batch. So yeah, I'll hand back to Mahesh now.
Thank you, Rinaldi. So let's begin our Python Melbourne Meetup first talk. So I'd like to request Akshat Soni for the talk on the Python design pattern. He is currently working as a software engineer on NPM.
Hello. All right. Thank you so much for being here. It's lovely weather today, and so good to see you all. And before I begin, I'd like to give a special shout out to Renaldi. It has been almost, I completed a year yesterday. I had my first ever talk in Melbourne Python just 28th August 2024. So I'm back again, and it's so good to be here. All right. Thank you. So, about the topic today. So, you all are, I'm assuming, from software development, IT analysts, system analysts, different backgrounds, and some of us are coding as well and using different Python frameworks. So, the framework should be like Django, Flask, Fast API, and we love to use it. But there are certain things that we may not understand perfectly, and those are based on design patterns. So, I was like, let's talk about design patterns. So we'll go through how, why, and what. But before we start, I will give a brief introduction about myself. I'm currently working at NBN. I work for Deakin Talent, that is under Deakin University. So I was a student ambassador there. I studied at Deakin University, completed my postgrad from there. And before that, I was working in Global Logic back in India. And now I'm here. So, agenda for today. We'll start by understanding what is design patterns, what are some popular choices, what are the types of design patterns, then why you may want to use or understand them. Then we'll have some code samples which will allow you to recall some of your code, and you'll be able to relate to how it actually relates to the design patterns. So what is a design pattern? It is so I've divided it into two sections. First, what it is and what it is not. So first is like it is solution to common software design problems. So basically, there are a lot of problems that we see in day-to-day problem solving journey that you may want to solve something, and it's like you reuse the code, but you can solve it using some design patterns. So I'll show you what types of patterns are there, and you will understand as we go. So it is a conceptual framework that guides developers to write efficient code. And what it is not a ready-to-use code snippet that you cannot directly drag and drop. It helps you understand how the code is written, and with the evolution of AI, you all are using pretty much to generate the code. So you need to understand as well what it is giving out as output. And if you know these design patterns, you can take help from AI more efficiently. And it is not the universal solution. So yeah. And one last note is that it is meant to be used in synergy. So what does that mean? There are different design patterns for different problems, and in a large application, you will use it in synergy, like combination of different design patterns. Yep. So about the types, there are basically three types. Creational, which is like how the object will be created. Other is structural pattern, on how it will assemble the objects for a larger application, and how the objects will behave is covered under behavioral patterns. So, what are some popular choices? For creational, we have singleton, then factory method. For structural, most common are decorator and facade pattern. Then for behavioral, we have observer and strategy. So let's go through them one by one. First, we start with creational pattern. So first is singleton. it is, as I said, a creational pattern, which is basically using a global object that is accessible to all the parts of application. So it basically uses global access point, and most common example of that will be database connection pool or a logging service. So for example, if you want to log something in your application, then there is a common object that you use with different methods. So it is a single object that is covering the logging for complete application. Now, there is factory pattern, another creational pattern that when there is a require. So let's understand this by directly the example. So notification system that supports email and SMS. So as you can see, there are different types of notifications that you want to send, but it is ultimately a type of notification. So you can create a factory that will produce different type of objects. Will be different type of notifications. Then we have decorator. So it is a structural pattern, and it is basically used to add additional behavior in your objects. So decorator is a very familiar term if you are a Python developer. So they have decorator function that you can insert a function that will add additional functionality. For example, if it prints something, you can additionally add some logic over there and use in decorator. Now for facade, facade is basically, as you can see in the example, it is simplified API for database or multimedia operations. So if you have multiple functionality in your application, you can create a facade of that, and it can extend the functionality to some other part of your application. Yep. Next is observer. So observer is a very common pattern that is used nowadays. So best example would be the PubSub subscription. So you subscribe to a particular object, and whenever there is any update, you get a notification or something like that. Other would be GUI event handling. So if you are building a UI and there is a particular mouse event that you can capture, or a key click, something like that. Then after that we have a strategy. That is another behavioral pattern. It encapsulates different algorithms that you can use in your application. So for example, there could be sorting algorithms you may be using in the application, or there is a payment method option in e-commerce applications. Now let's go through some code samples. So for singleton, you can see that we have new function that basically checks if there is any existing instance of the application. It will return that instance, and if you log it, you can see that same instance is maintained across the application. So for factory, we have an example that you can see. It builds the notification class at first, then it is inherited in email notification and SMS notification. And when you want to create a notification, you call the factory, which is extended in email factory and SMS factory. So basically, you simply create an object of this, and you can call the same method, and it will send the notification from the factory. Now this is observer code pattern. So in this, you can see there are two methods. One is for registering your listener, and that is to another one is to notify all the observers that are available. So when you subscribe to this particular object, whenever there is a change, it will send out notifications to all the subscribers. Yeah. So thank you so much for listening. This is QR code to my LinkedIn, and yeah, we can connect and discuss. If you have any queries, let's discuss that.
Thank you, Akshat. If you have any queries, please feel free to ask with Akshat. So, do we have a query? No, I guess.
Any questions?
Are there any sort of libraries built out of this so we can call out those functions and later on use it, or is it like just one that?
Yeah, so as I said, it is not a perfect library or any code snippet that you can reuse in your application, but it is a style of developing some library, something like that. So if you are building a library, that would be an example of facade pattern that I showed.
It's a pattern.
Yes.
Thank you.
Any other questions on the floor firstly?
No, I guess now it's time for reconnection, and please free to connect with each other, and we'll be meeting at 7 p.m. now. Thank you. All right, let's get started. I hope you had a good time knowing each other. So for the second talk, we have Edward Schofield. He is the director of the Python Chambers. Now he'll give a talk on better DataFrames with the Polars DataFrame library. Edward, please.
Thank you. Hi, so I first gave this talk at PyCon Australia last year. Was anyone there during that talk? Okay, just that's useful to know. So that means I can recycle my jokes from there. All right, so I'd like to start with an overview of databases and data frames. I'd like to then go over the history of data frames, and in particular the pandas package, go over design limitations in that, and what I see as a kind of shift in the ecosystem regarding data science and data frames in particular that's underway right now. Right? So then I'd like to point out some alternative data frame libraries which have various advantages, and discuss how you can achieve interoperability between pandas data frames and other kinds of data frames, which are becoming more numerous, more widely used in lots of contexts. And then I'll have a few minutes to just ruminate on this this topic of creative destruction in open source. There's some ideas that kind of came to me as I was developing this. I didn't actually have time during the Python conference talk last year to kind of give my 3 minutes on this, so I'll do that now. And I'd like to give you some recommendations as well about where to go from here if you're interested in working with data frames in Python. And we'll have time for Q&A. Also, since the first talk was quite short, I've offered to give a kind of demo after this talk on a different topic, which is just kind of spontaneous. I've been playing a lot with AI coding agents in the last month or so, particularly Claude Code. I'd like to demonstrate what I've sort of discovered about that. So that's quite fun. I think that'll be good. And nothing's prepared, so I'll just add with that. So my name's Edward Schofield, or Ed. I co-organized the Melbourne Python Meetup for quite a long time, until COVID slammed it, the doors shut. I did a PhD in machine learning, finished that in around 2008, and I was once upon a time the maintainer of the SciPy package when I was procrastinating writing up my PhD thesis. Wanted an excuse not to do it, so I became involved in the SciPy project, and I happened to kind of need it as well, which helped for my research. I founded a company called Python Chalmers in 2010, and we're still going. We've run 700 training courses in Australia and other countries. And I was involved in a project called Python Future back when Python 3 was the future. That's long in the past by now, so I consider that to be deprecated along with Python 2. For fun, recently I've been doing some study and research in reinforcement learning, which is, I think, a really exciting field. Anyway, that's just a bit of fun. So now I'd like to start with just a kind of very selective look at databases and data frames. Okay, so there was a big bang, and then 13.8 billion years happened, and then we come to this, the 1970s, when there was SQL developed, and the S language for statistics at Bell Labs, and VisiCalc, the first spreadsheet tool. And in the 1980s, we had S with its data.frame class. Python came out in, I think 1991 was the first public release or something like that, but it was in development in the late 80s, and so was R, although the first stable version of R was later. In the 90s, we had the numeric library in Python and NumArray. There are actually two, even more, competing libraries in Python for working with arrays, and that was a bit of yeah, there was kind of innovation, but it was holding back the ecosystem in Python. So, MySQL came out then, Postgres in 2000. In 2005, NumPy, I guess it had been developed prior to that, but it really was sort of really getting rapid adoption. And NumPy, I'd say, is the primary reason Python is the kind of predominant language used today for scientific computing and for data science. Okay, so it really it unified those earlier array libraries, and it allowed so much innovation to happen. It allowed it sort of drew a lot of people from other ecosystems toward Python, because Python now suddenly was not just a high-level, easy-to-use language, but it was also fast for a lot of operations that were necessary in these kinds of fields that used a lot of data. SciPy had releases around that time too. It was originally kind of a MATLAB clone, but grew beyond that. Pandas came out, in 2008. Okay. Pandas was originally a kind of skunkworks project by someone called Wes McKinney, who was working at a hedge fund, and he'd never coded before. So that sort of shows in some of the design decisions of the Pandas library. But it made it possible to work in Python for things that other people would have used R for around that time. Okay, so R was kind of coming along strong around that time, and a little bit after with the whole sort of tidyverse in the 2010s. In 2009, there was Spark and BigQuery, and all of the noise about big data started in around 2009. So then in 2016, there was something called Apache Arrow, which turns out to be really, really important. It's actually co-founded by the author of the Pandas project, Wes McKinney. He originally said that Pandas was, he cared a lot more about it being usable than about its memory layout and things like that. And then it turns out that from about 2015, he spent most of his career focusing on exactly that, memory layout, and all these kinds of issues that previously he'd considered to be not that important, because he realized, oh, actually, they are important. So Pandas has some fundamental kind of design limitations that I'll mention. Now, recently, we've got a kind of a bunch of projects that are innovating, and particularly around column-oriented analytical database-type queries. Okay? So DuckDB is one of those. It's a column-oriented database, unlike the traditional row-oriented databases like Postgres and so on. Polars is a Python library and a Rust library for working with DataFrames. It supports lazy and eager computation. IBIS is another interesting contender. It's actually co-founded by Wes McKinney too, as a project. I'll mention that. So this is the big picture as I see it. Data scientists are not yet really benefiting from decades of research that's gone into relational databases. Okay, SQL databases I mentioned, 1970s. I think this is about to change. So there's a kind of historical gap that data science tools like Pandas and NumPy and so on were built by scientists and statisticians, not by the database community. So there's a kind of community gap there. And those tools like NumPy and Pandas are optimized for familiarity and flexibility, but they're not optimized for query planning and storage engines and things like that. Okay. But there's a bit of a trend now that modern libraries are merging these two worlds. Okay. Yeah, so there are some efforts to harmonize the best of modern SQL with its relational algebra and Python fluent DataFrames. Yeah. So what is a data frame? Well, a vector, think of a sequence of numbers. Matrix has a two-dimensional sequence of numbers which have the same data type usually. And a data frame we can think of as being a two-dimensional structure, a bit like a matrix, but where each column has its own data type potentially. Okay, so heterogeneous data types across the columns. So usually these are used for linear algebra, the kind of computations that happen for image processing and for neural network training and things like that. And data frames are more to do with well, they're used for a lot of purposes, but it tends to be in-memory analytics, and where you may have columns of strings and things, not just numbers. Okay. So this is the idea. You've got heterogeneous columns. Often they're called series, at least in pandas and polars, and I think ibis as well. Okay, so a series is a column with a consistent data type, but they can each have their own data types. Okay? Columns can have missing data as well. This is another point. Matrix libraries like NumPy don't really support missing data. There is a masked array class in NumPy, but no one really uses it. And it doesn't really serve the purposes of people looking at data analytics for many tasks. The kinds of tasks that people have used Excel spreadsheets for when they shouldn't have. Okay, there are lots and lots of spreadsheets out there in the world which are getting too big for spreadsheet software, so they should probably move out to one of these data frame libraries. What is the difference between a database and a data frame? Well, traditionally databases support these concept tables, views, procedures, and they have a SQL engine which does some query optimization. They tend to be declarative. So you write SQL code, which is a big string. It's a bit verbose, but it does the job. So it says what you want, not how it should be produced. And that's the meaning of declarative. Whereas data frames tend to be in memory mostly. Okay, these don't have to be in memory, they're on disk. So these tend to be in memory for speed of iteration. When you're analyzing a data set, it could be in any field, but recently I gave a course in New Zealand to some biologists who are working with single cell RNA data, and they work with large data sets, and it's too cumbersome to query it from databases all the time. It's nicer, and I guess, it's nicer to work with those things in memory. Okay, so row-oriented databases, like those on the left, are optimized for joins and lookups and CRUD-type operations, whereas data frames tend to be column-oriented. Okay, and these are used for these kinds of tasks: data cleaning, filtering, reshaping, constructing pivot tables, things like that. There's this guy on Twitter, Big Data Borat. He wrote this: in data science, 80% of time spent prepare data, 20% of time spent complain about need to prepare data. So that was quite appropriate, I thought. There is a kind of necessity to munge and monkey with real-world data sets, because they tend not to be all clean and tidy to begin with. So here are some SQL databases. There are a lot of them. It's a big deal. There are all sorts of other kinds of non-SQL database engines too. So the concept of databases is much wider than that, and there's a lot of research that's gone into this. And I mentioned query optimization. There tends to be a kind of a query, and underlying there's this relational algebra, which is well studied. Most universities in the world offer courses in databases that include, the theoretical underpinnings of relational algebra. So it's sort of well optimized as well. Yeah, there's a lot of solved problems that haven't been brought into regular usage among DataFrames yet. But lazy evaluation is a key feature of this. Right? Now I think a convergence is happening. So what I see is that DataFrame libraries tend to be adopting database style optimizers, while SQL engines, which have traditionally been kind of more cumbersome to use, are starting to expose DataFrame-like APIs. Okay, so this is an interesting kind of takeaway to be aware of. All right. So now about the pandas package in particular. So for the last few years, it has sort of seemed like we have pandas as sort of a clear choice for Python DataFrame use. At least for, I guess from about 2012 to maybe about 2022. It's powerful, but it's got an enormous API that's quite inconsistent, although it's been getting better. It's buggy, a bit clunky. It's known to be quite slow, but it's kind of been the heavyweight champion in terms of popularity. And my colleagues and I at Python Charmers have tended to teach this rather than other DataFrame libraries because it's kind of just been a no-brainer until maybe about a year and a half ago. So things have been changing, and now there's a lot of innovation here. Okay, so there are some of the more recent projects which are in some ways contenders, looking to capture some of the users from the Pandas project. And I've been using and recommending Polars a lot. It's based on this Apache Arrow project I mentioned, which is a cross-language kind of a set of libraries and specifications for how memory is laid out to do, along with missing data handling, different data types and things like that. Some of these packages on the bottom are tools for working with like distributing Pandas DataFrame workloads on a GPU or across a cluster. This is an interoperability library. Okay. So I mentioned NumPy before. Let's say this is Python's most important C extension, and it's the basis of Python's science and data ecosystem. It's fast, simple, it gets the job done. But it's CPU only, which is a downside, and it's why it's not used for training neural networks. And it's eager. What is that? Sounds good, but no, eager's, it means it doesn't have the opportunity to build up a kind of an optimized query plan like databases do. Okay, just if you tell it to do something, it goes and does it, even if by rearranging operations it could get a faster result. So I mentioned I showed you this slide, but what's different about Pandas in particular is it has this concept of a row index. Not all DataFrame libraries do. Polars one doesn't, for example. It's an interesting design decision. It makes it more complex for beginners, but can potentially make some operations more efficient if you use the index well. So I guess I'd like to say 3 cheers for Pandas. It's been very beneficial for the Python ecosystem, drawing in many people into it and made Python a viable choice for when it otherwise wouldn't have been. Okay? But there's this Marie Kondo, this lady who kind of has this design sort of. She helps people throw away their junk, and she has this saying: if you want to throw something away, first of all bless it, and then throw it away. Okay? I think it's maybe time to do that with the Pandas package. We bless it. Thank you. It's been useful. But no, it's kind of it's got various design limitations that will never be addressed, I think. So here are some of the weaknesses of it. It wastes RAM, and you'll need 4 times, maybe up to 10 times the amount of RAM as the size of your data set. never support lazy evaluation due to the design. CPU only because it's kind of built on NumPy. And it's got pretty messy support for different data types, which is kind of constantly growing, and we're all a bit broken in terms of categorical data, native string types, and missing data, things like that. It's also single-threaded. I mentioned it's got a huge and inconsistent API. And in particular, its API doesn't fit distributed computing models, although some projects have tried to copy the Pandas API for distributed DataFrame objects, which isn't a good choice, probably. Yeah, anyway, there's some weaknesses there. So some of these are my observations, and some of them are from a blog post by the author of Pandas called 10 Things I Hate About Pandas. You can Google that. He gave that talk to a couple of user group meetups in the Bay Area and then wrote a blog post about it. Basically, Google 10 Things I Hate About Pandas. So yeah, now Pandas 2 was released 2 and a bit years ago. And it offers somewhat experimental support for using the PyArrow package as the backing store instead of NumPy arrays. And there's a copy on write feature designed to make it more memory efficient in some cases. But Pandas 3 is still up in the air. There was a decision to adopt PyArrow types by default, and then that decision was reversed. And, no one's really sure what it's going to look like. I think this is going to go ahead now. There was a concern that the PyArrow library increased the size of the Pandas package from 100 to 500 megabytes installed. So anyway, yeah, so it's not happened yet. It may happen sometime, but I think it's got obvious limitations and it's so far behind it's not going to catch up. It's got a huge legacy code base, and it should, as a project, aim to maintain some compatibility with the billions of lines of code out there in the wild that uses it. So I think it's the end of the road. So here are some alternative DataFrame libraries. This is the star history as of my talk last year. I haven't checked it recently, but you see the rapid growth in these two, Polars and DuckDB in particular. So at some point they're going to catch up in popularity. I mentioned arrows. This was the result of a collaboration between Hadley Wickham of the R community and Wes McKinney. It's a standard format for interoperability, and so it's an ecosystem. It's a kind of unified cross-language computing layer for data analytics, optimized for CPU cache affinity and things like that. So to solve these kinds of problems, cross-language, it helps with larger than memory data sets, good support for missing data, and so on. Now, in Pandas, this is extremely wasteful. This creates a temporary array in memory of booleans, then another array, which is a subset of the original one, and extracts one column from that, and sums that up, just to come up with a single number. Whereas there are better ways to do that. Now, Polars is one. It's fast, it supports lazy execution, it's got a nice API, like the R libraries, like dplyr. It's mostly for in-memory computing. You can go up to about 4 times RAM, maybe 10 times RAM, but it's not its sweet spot. There's a tool called DuckDB, which is similar, which is becoming very popular. This is also based on the Arrow specification, but it's a database. It has a SQL-like interface. It's got its own DataFrame interface in Python, but it's not very easy to use. But there are other front ends for this. It's a great kind of backend store for data. Here's someone's view of the differences between some of these tools, which I found online. Yeah, so let's say the Polars library does have query optimization, and some, yeah, I agree with that. All right, now there's IBIS. Has anyone heard of IBIS? Yeah, a couple of you have. All right, IBIS is a tool for scaling data frames with Python to big data engines. So it's like a front end, and the back end is any one of about 20 different database engines, including DuckDB and Polars, but also BigQuery, ClickHouse, and many others. So it's a little bit like SQL Alchemy in that it's a kind of compatibility layer, but it's for analytical queries. It's quite actively developed. And I don't think it's as mature as Polars. I want to love it, but I don't yet. It's not, yeah, it's got some rough edges, and its docs are not as good as they should be, and so on. So if you want to make a contribution to an open source project and have a big impact, this would be a good one to adopt. So here are some of the backends that it supports. It's a brilliant idea. The idea is that it's using you can just sort of use a nice DataFrame API, and it'll be translated into the appropriate SQL dialect for your database. And then, of course, each database knows how to optimize queries on itself. So you get great performance, and you get the ability to just migrate your data from one database to another. It's a brilliant idea. A bit like SQL Alchemy, that the role it plays in for row-oriented databases. It's got this deferred execution model, so you build up a query, and then when you're ready, you hit go, and it actually translates it to the SQL query and issues it to the database. And it does the heavy lifting, and then we'll give you some data back over your slow NBN connection after filtering it and things like that. And that's a good policy. Yeah. So you wanted the database to do all the hard work rather than sloping down over the little thin wire. So I saw this interesting article. Yeah, I think some of these tools are good for that. So yeah, I think it's got a great design, but it's not quite there yet. Just a mention of some other tools. This is a GPU-based library. I think it's sponsored or maybe even just made by NVIDIA. So they want to sell GPUs, so they think, oh, Pandas has a lot of users. Let's make a tool that allows Pandas users to buy more GPUs. So that's what that is. Modin and Dask are both tools to distribute DataFrame operations across a cluster of machines. And they aim to be API compatible with Pandas, which is a questionable choice because the API is not, it doesn't have the right grammar for distributed computing. It's like eager, for example, and it's the wrong model, but they've tried to copy the API for compatibility. Okay, so lazy evaluation is a key feature of distributed computing systems, and Pandas doesn't really have the grammar to make users mindful of the intricacies there. Okay, so anyway, here are some benchmarks. These are changing all the time, but basically DuckDB and Polars are extremely fast, and everything else is much slower. Okay, so now just a bit about compatibility. Arrow is designed for cross-language support with a zero-copy interface to kind of query and write data between different languages. if you're looking to support multiple data frames in Python, there's this so-called PyCapsule interface. It's becoming a standard for libraries to support this. Okay? And yeah, just like there's a similar kind of interface for arrays, NumPy arrays, defines memory ownership and lifetime and things like that. So if you want to be able to accept different kinds of data frames into your project, like a visualization library or whatever, without depending on all the different libraries, hasn't been clear how you do that. But now there's a kind of standard that's emerged, and that's this tool. Okay? So libraries like Plotly or Altair for visualization now support other kinds of data frames, not just pandas ones, by using this as a compatibility layer. There's an example of that's from the Narwhal's website. Okay, so you can just kind of add this decorator to a function, and instead of taking a pandas data frame and returning one, it sort of translated efficiently without memory copies to support this API, which is the Polars API, and then it'll kind of translate it out again to give you back a pandas thing or a modin thing or whatever. Now what's this about? That's really small. I was just showing you, at least back then, the Seaborn, does anyone use Seaborn for visualization? Yeah, a lot of you, okay. Seaborn, it's nice, but it hasn't really had a release since April last year. No, April 2024. So it's not very active, and they still depend on pandas. But this is changing gradually. A lot of projects that used to depend on pandas no longer require it. Okay? So you can pass in other kinds of data frames instead. There's this nice UV tool which has become really good in the last year or so. This shows which packages I had installed on our servers which depend on pandas. And it looked like that 10 months ago. And I checked just on the train on the way today, and it pretty hasn't changed. Okay, so, but gradually that will change, okay? Gradually these projects will. I think Plotly, for example, Plotly no longer requires pandas. Anyway, there have been different approaches tried. This one was an early idea, but it's deprecated now. There's Narwhal, as I mentioned, and so on. So there's a quote about that. He said, "Oh, I'm sorry for having introduced this interchange protocol. It's turned out to be problematic, blah, blah, blah." So the long-term future of this particular way of doing compatibility is quite bleak, but there are others. So the status is still in flux. That's where it was 10 months ago, and that's where it is now. Similar, so there's this obligatory XKCD calling, how standards proliferate. So that's happening a bit now with DataFrame libraries. Okay, so just a comment here on creative destruction in open source. So Pandas has been a standard since about 2012. And you know the Python, what's it called? The Python, I don't know, you type or this, what's that called? The Python, whatever. There's sort of these little kind of principles that guide the design of Python packages. The Zen of Python, it's called. It's part of the Python style guide. So yeah, there should be one, and preferably only one obvious way to do it, versus there should be a better way to do it. Okay, which one do we like? All right. So if you go for this, there should be one only one way that you get these kinds of positive outcomes you're looking for: consistency, simplicity, and so on. But what if there really is a better way? So there are pluses and minuses. Okay? Each of these has its downsides. So compatibility comes with conformity, perhaps, consistency with monotony, and so on. Okay, so there are downsides to each of these, and even our best efforts to create good standards can be stifling eventually. So yeah, there are these kinds of downsides. Now, what if we prefer the other option? There should be a better way. Okay, you get all these benefits. Oh, that looks good. Creativity, diversity, exploration. Okay, so these have also got their downsides here. Inconsistency, fragmentation, conflict, chaos, incompatibility, and so on. Okay, so this was an interesting comment made by Wes McKinney back in 2011. Fragmentation is killing us because at the time Pandas wasn't yet a standard, and he lamented the fact that there were all these competing DataFrame libraries. And anyway, we're kind of going back toward that now. So yeah, a magnet always has two poles, even if you try to cut it in half. So there's a shadow side to any of those. So some final recommendations for your next project. Now, first of all, why your next project? First, I'd say don't fix what ain't broke. Okay? So you might have millions of lines as an organization, or you for your own personal projects might have thousands of lines of Pandas code. That's a kind of investment that you don't necessarily want to lose. But if you don't have a legacy of Pandas code, choose Polars or Ibis. Okay? They're faster, they're more memory efficient, they're more future-proof, and the APIs are better. So Polars is for a single node, but Ibis works well on a cluster too. So if you've got less than a gigabyte, I'd say, of data set size, go with Polars for your next project. If you've got up to 100 gigabytes, I'd say also Polars. If you've got 100 gigabytes to a terabyte, then I would go with a DuckDB backend and Ibis as a front end, because this is a much nicer front end than DuckDB provides. And buy lots of RAM. And if you've got more than a terabyte of data, then you probably want to go with some larger tool. And I'd suggest if you use Ibis as a front end, it's going to be give you the benefit of the nice API. So final conclusions here. Amazing work is going on based on Apache Arrow. Next, let's say Pandas will slowly become irrelevant. The long march has started toward irrelevance because it's got design limitations that will never be addressed. Like this single-threaded, copies memory, and there are lots of other options these days. And there's a library called Polyglot, which I think is called Polyglot, which is used by Ibis under the hood, which can translate between different SQL dialects. It's pretty cool. So if Pandas works for you, fine, keep using it. But if you don't have a legacy of that code, choose these other options that are faster, more future-proof. And interoperability is gradually improving. It may take some time yet. Okay, thank you very much.
Thank you, Ed. If you have any question, please feel free to ask for him. Yes.
How does it really find a working Polars? Like, can you influence it? Can you do indexes like SQL databases?
Good question. I don't know a lot about it. If we pull up so the documentation's quite good. I think, so when you call .collect, there are a bunch of keyword arguments you can pass to that. So Let me find the API for that. API reference code, collection, streaming, query execution. That's the same page as last time. I think I'm looking for the reference guide, and it's a different website. Okay, this is what I wanted to show you. So that's, I've never actually, oh, it's not sharing. Right, how do I do that?
Just quickly turn off mirroring, turn back mirroring
Turn
on,
back,
and then you should be good.
thanks. I could, then I wouldn't be able to see it. I'm nearly there. No, okay, that's failing. I will drag it. Let it take. All right, so that's small. Some of the keyword arguments you can pass when you call collect. Yeah, so but I can't really comment much more than that. Any other questions? Yes.
Sure, hang on. I'll bring the mic up to you.
That's a really amazing talk. I'm just wondering, let's say I am about to leave my office at the end of the day, and I just want to do a really simple OLS. Well, since you are the maintainer of SunPy, you probably know this much better than all of us.
So you want to do a simple what?
OLS, just do a simple
regression.
regression.
Okay, yeah.
And right now, my default choice will be like input pandas, the pandas raise CSV, and I just dump all them to the SunPy, and I get my result, and I send it to my supervisor, and I go happily.
Yeah.
I'm just wondering if I change if I change the pandas to Polar, can I do the same thing? Can I just dump the Polar into the SunPy framework and get the exact result?
Yes. Into SciPy, is that what you said? Yes, you can. So stats models is perhaps the standard way to fit a regression in with pandas DataFrames, and that doesn't support polars, but there are alternatives that do. So instead of stats model, if you're using polars, you'd use something like Glum, which does support polars and other kinds of DataFrames too. I think. Let me try to make that bigger. Yeah. So this will help you fit regression models, and this supports other DataFrame libraries like polars. Yeah. So yeah, generally with tools that are being updated regularly, you'll be fine with other DataFrame libraries, but the tools that haven't been updated actively as projects for several years might still only support pandas. Yes, but there's a shift happening right now. So the more actively developed projects are gaining support for other DataFrame libraries.
So regarding on compatibility, right now the pandas is still the dominant.
Yeah, and in fact, one benefit to pandas over the other is because it's been around for 13 years or something, there's a lot of pandas code online. So AI coding agents are really good at producing pandas slop. Yeah? So if you want to, if that's a benefit to you, then good. It may be inefficient and buggy and so on, but these kind of LLMs can generate pandas code. Yeah.
Right, thank you.
Sure.
I just wanted to ask a bit about, with the increase of all these new libraries, you're getting multi-processing in these systems.
Yeah.
How is that working with the Python GIL? And how does that work with, say, using the multi-processing libraries of Python?
Yeah, okay, good question. So C extensions have been able to drop the GIL since 20 years ago or something. And so NumPy does, for example. If you multiply two matrices in NumPy or PyTorch or something, it'll drop the GIL. So the GIL only affects Python objects, either run by the Python interpreter or by certain parts of the C interface to Python, which hold the GIL, but they control it. So Polars is written in Rust, so Polars drops the GIL too. So there's no GIL to worry about at all. Pandas suffers from it though, because Pandas code has a lot of Python in it. It's got a Cython core, which in theory can drop the GIL, but there's a lot of Python layered on top of that. So Pandas in practice is hampered by the GIL, so it can only run single threaded. So Pandas might benefit from these coming developments, but it's just playing catch up. These other libraries don't have that limitation to begin with. Sure.
Cool. First of all, thank you for coming. Great talk.
Thank you.
I just wanted to ask, you said that you don't yet love IBIS. What are the features that you are finding that it lacks?
I found it a bit buggy and not very well documented. Now the bugs are not terribly important, but they've just been making my life annoying. So for example, we build course notes as PDF files for training courses of Python Charmers, and they're auto-generated from Jupyter Notebooks, which display data frames and things like that. IBIS's default representation of a data frame includes Unicode characters that break our LaTeX pipeline. Now, I've complained about this in a GitHub issue, and the response was, Unicode's fine, it's 2025. And I kind of thought, oh, all right, so if I were to kind of adopt it for that task, then there's a bunch of work there. So, and other things as well, that it's just, if you look at the Polars expression API, let me show you this. It's on a different league. So Polars expressions API. Now, bigger? Okay, that's bigger. All right, so now what am I trying to do? No, it's mirroring. There we go, expressions. So Polars has got all these expression methods which are implemented. And this is, I think, just that one category. And there are all these groups here of other categories. Okay, so all these different methods available on, for example, on strings and things like that. Okay, so all these are implemented. And because they're expression methods, they all were evaluated lazily and so on. So the docs are amazing. The comprehensiveness is also very impressive. And IBIS, the documentation may be 10% the size of this. So that's a factor. I can't recommend it as highly because if people run into a limitation with IBIS, then they're stuck. Yeah. Although it's got a great design, it just needs this kind of effort put into it to kind of complete it.
Just keeping out of the time, I think that's pretty much going to be the last question that we will take for the night. But if there's any other questions, you can pretty much feel free to grab it after this as well. But yeah, let's put our hands together again for
I said I was going to show you some of my lessons that I've learned about AI coding agents, so I'll save that for another time. Thanks.
So yeah, I think we are to the end of the segment. So thank you everyone for being with us today. So it is love. Sorry. Yeah, thank you so much for everyone for showing us so much love, and we hope we'll be meeting for the next meetup as well. Thank you.